Okay, so you guys want to go over number 2?
Yeah.
Yes. So number 2 gives you nanometers and wants you to go to what?
Energy.
Go all the way to energy. Okay, so we're going to start with a wavelength of 25 nanometers. What's the first thing we need to do?
Let's see.
What's the first thing we need to do to this?
Convert it to meters.
So you can write like 25 times 10 to the negative 9.
Yeah. Let's convert it to meters. And let's just do it the easy way. Okay, this is non-calculator. We don't have to move any decimals and we don't have to make any mistakes. Okay, so we've got it to meters. Now what I'm going to suggest that we do, even though we want to get all the way to energy, I'm going to suggest that we take the 2 formulas. The speed of light is wavelength times frequency. I'm going to suggest we do this first and solve for frequency, and then we use the second formula, feed in the frequency, and solve for energy. Okay? These, the C and the H, are constants. C, we said before, is 3 times 10 to the 8th meters per second, and I always use the rounded number unless it's a free response kind of problem, then maybe I'll use the other one, but they really don't care. If you use 3 times 10 to the 8th, you'll be fine. Okay? H is 6.63. I often use that rounded number. The green sheet says 6.626 times 10 to the negative 34 joules times a second. Okay? So you got to be, be conscious of your units. Okay? So if we plug this in, I'm going to solve for frequency, so I'm going to rearrange this formula, and I see that speed of light over wavelength will give me frequency. So I'm going to have 3 times 10 to the 8th meters per second over 25 times 10 to the negative 9th meters. Now we are going to use a calculator, but I want you guys to practice part of the non-calculator-ish, okay? So guys, just tell me 3 over 25. If you had to simplify that, that would be like 1 over what? If it was 3 over 24, what would it be?
1 over 8.
1 over 8, okay? So I just want us to kind of practice with that. It's like 1 over 8, and then what would be the exponent? Times 10 to the what? 17, because you're going to have 8 minus a negative 9, okay? That's about what we're going to get for our frequency. See how we're predicting? Now, can you guys throw that in your calculator? Let's all throw it in our calculator and see what we get, okay? Remember, on these calculators, you're just going to hit 3EE8 divided by 25EE negative 9. Anybody get 1.2 times 10 to the 16th? Okay. And if we think about how this jives with it, 1 divided by 8 is 0.125 times 10 to the 17. If you move this over 1 to put it into standard form, which is when you just have one number to the left of the decimal, if we make this bigger, so we have to make that smaller, you see that we have the same, okay? And again, this stuff, I really want you practicing that non-calculator all along, because exponents just freak people out, okay? People just don't feel as confident doing that. So if we can do some predicting and then checking, then you're going to get more confident about how you're working that through, okay? All right, so we're not done with our problem. We're going to focus on this. And so now that we have this frequency, we want to plug this into this formula. Okay? So, energy equals Planck's constant, 6.626, times 10 to the negative 34 joules times a second, times the frequency that we just got. 1.2 times 10 to the 16th hertz, or 1 over a second. Okay, or second to the negative 1. However you want to write that. Okay, I like writing second to the negative 1 or 1 over a second rather than hertz, because you can see how things cancel out. Okay, when we put this in our calculator, okay, and even again, let's do a little prediction. 6.5 times 1.2. Do you see how 6 times 1 is about 6? We've got a little bit more than 6, a little bit more than 1. Maybe that's going to be like 8 or 9. Y'all with me? Okay, so 9-ish maybe. What is our exponent going to be?
18.
6.6 times 1.2. Yeah, okay, actually it's like an 8. So this would be 10 to the negative what?
18.
18. Okay, so that's kind of an estimated, all right? And then let's throw it in our calculator and see what we actually get. Has someone already done it? 7.95 times 10 to the negative 18. And notice the second is on top and on bottom, so that will cancel, and so our unit will be in joules. And that is the first part of our answer. Do you see how close we were? Remember I said it's going to be 8 or 9, but this is what I want to check for, the exponent. I just want to gain some confidence in working with exponents.
So it's just putting numbers into the equation.
That's it. That's it. Okay? Yes, ma'am.
C is speed of light. So what
Yes.
is H?
It is Planck's constant. Okay? And Max Planck figured out that all energy is incremental. We have quantized energy. You can't have any, like electrons. It actually kind of comes from this. You know how we have energy levels? And you know how electrons can jump between energy levels, but they can't jump in between? This is what this relates to. So Max Planck figured out what that, we call this a quantum of energy. Remember how yesterday we learned about quantum numbers? It all kind of goes together. So all of the energy of electrons are in increments. And this is the smallest increment, so that we use that number. Is that cool? So that's kind of how he got that. Okay? And that's given. It's on the green sheet. You never have to memorize it. You just have to use it. Okay? Now, in the problem, if you read it carefully, it asked you for two energies, didn't it? It asked you for the energy per photon. A photon is just a particle of light. That's kind of a funky thing to say. Light has a dual nature. It's got a particle nature and a wave nature, and we'll talk about that in more detail later. But when you talk about a photon, it's like a particle of light. So this is per one photon. Okay? Whenever you figure out the energy, this is the frequency of one photon, or all the photons that look like that. This is the energy of one photon. The second part of the problem asked you to figure out the energy of a mole of photons. How do we...
So we just multiply it by 6.
Can I help you? Sure, it's right. There you go. So, yes, we just multiply by 6.02 times 10 to the 23rd. So I'm going to take this number, 7.95 times 10 to the negative 18 joules per photon. And remember, we can have a mole of anything. So 6.02 times 10 to the 23rd photons is equal to 1 mole of photons, right? And so, if y'all can keep calculating, we had our 7.95 times 10 to the negative 18 times 6.02 times 10 to the 23rd. Whew. I'm going to put it back in scientific notation because there's a lot to write. So I'm going to get 4.79 times 10 to the, right? It's going to be around 7 or 8 or 7 or 6. It ends up being times 10 to the 6. I get 6, right? 4.79 times 10 to the 6. The photons cancel, and so it's joules per mole of photons.